Hi, I'm Sujata. I'm working as assistant professor in AML department. Today we are going to discuss about the K-means clustering algorithm. This is this is a data mining unsupervised category data mining algorithm. This is mainly used for clustering the data points into K distinct clusters. Means data points within the cluster are very similar. Data points uh, data points in one cluster are dissimilar to data points in another cluster. The main goal of this algorithm is minimizing the variance within each cluster while maximizing the variance between the clusters. Okay, here we have to understand before going to the algorithm, we need to understand three keywords here. One is cluster. As I told, cluster means data points that having same properties or same kind of features. This algorithm works on centroid concept. Okay, what is centroid? Centroid means the central point of a cluster. Here we have in this algorithm we have to use the Euclidean distance. Here in clustering algorithms we use the similarity dissimilarity metrics for distance calculation for distance calculating. Here, distance metric is in K-means algorithm. Distance metric is Euclidean distance. See, in this image, first data points are like this. After applying K-means algorithm, these data points are categorized into clusters. Cluster is nothing but a group. So in here cluster in the K-means clustering clusters are non-overlapping clusters. We get non-overlapping clusters. K distinct non-overlapping clusters. This is the formula for Euclidean distance. So in 2D space, there are 2 points are there, P and Q. So this is the formula of calculating the Euclidean distance. Okay, then we go to the clustering algorithm. In clustering algorithm, first we have to choose based on some methods. By using some methods, I will discuss these methods later. For now, for the time being, assume k is some value. Means it indicates number of clusters we need. First, we have to initialize the k value. Means how many clusters we need. So here randomly we have to pick the centroids. Randomly take any randomly select few based on k value. For example, if k is 3, we have to choose the k centroid points randomly. Any centroid points. First, we have to choose the k value, means number of clusters. Next, we have to initialize the centroids randomly. You can select this k value randomly, or you can use some methods. I will discuss those methods later. So now assign each data point in the data set to the nearest centroid. First, we have to calculate the first take one centroid. first take one centroid, randomly choose one centroid, then calculate the distance from the centroid to each and every other points. So then we have to compare the distance. For example, we have to calculate distance from this centroid to this point, and from this point to another center point. So whichever is small, we have that point comes under that cluster, whatever centroid is there, minimum. Like that, we have for every centroid, we have to calculate the distances from this centroid to every other point. Like for every centroid, we have to repeat the same process. Then for every point, we have to check from uh, which centroid this point is, where this point distance is small. For example, this point distance is very nearer to this centroid than this one. So this point comes under this centroid cluster. Like that, for every centroid, we have to repeat the same process. See, assign each data point in the dataset to the nearest centroid. So the distance between data points and centroid is measured using Euclidean distance. We have to apply that centroid as one point, and that point as that chosen point as another point. We have to calculate the distance. So from that point, from every centroid, we have to compare the distances. So whichever is small, that point comes under that centroid cluster. For each data point, calculate the distance to each centroid. Assign the point to the centroid that is closest. Once all the points are assigned to the clusters, again we have to, starting we assume the centroids. Now we need the accurate centroids. So once all the points are assigned to the clusters, we have to recalculate the centroids. So now new centroid, we get new centroid by taking the mean of all the points in that cluster. So that mean value is the new cluster. The new centroid of each cluster is calculated by taking the mean of all the points assigned to that cluster. So new centroid is the average of all data points in cluster K. We have to repeat this step for all the centroids, for all the clusters. So repeat the assignment and update steps until centroids no longer change. If for the next step, if centroid is not changed, then we can leave. So final clusters, we got the final clusters with perfect centroids. So this algorithm comes under convergence when the centroids don't change anymore. But choosing the for getting the k value, we can randomly choose, or otherwise we can use these methods like elbow method. One method is elbow method, other one is Silhouette score, and the other one is gap static. There are some advantages of algorithm. Some advantages are there for this algorithm. Means it can work for larger data sets. It's very easy to understand and implement also. But yeah, So it will not, definitely it will converge to a local minima. This algorithm is very easy to interpret, but there are disadvantages also there. One is choosing the right k value is very challenging, and it is sensitive to initial centroids. Why? Because you have to randomly pick the centroids at the starting of the algorithm, and your assumption is spherical clusters. Spherical means same size and density, and it is very sensitive to outliers. It cannot handle the outliers. It works best only for continuous data, not categorical data. May not work well for categorical data. Here we can observe, we can understand this algorithm through this problem. See here, there are data points are there. These are given data points in a problem. So here we can choose, here k value mentioned, k is equal to 3. So here we need the 3 clusters. These data points we have to categorize as 3 clusters. So randomly we can pick any 3 points as centroids. So after that, first choose C1 centroid. Then from C1 centroid, calculate Euclidean distance from each other points. Here 2 times P1 is we have chosen as centroid. So from this point to every other point, we have to calculate the distances. Like that, for centroid 2 also we have to repeat the same. This one we chosen this as a second centroid. So from 8 4 to we have to calculate distance from every other point. Like that, we have to repeat the same for cluster 3, centroid 3 also. So we have to check. For example, 2 comma 5. 2 5 point is very nearer to C1 cluster than C2 and C3. So this 2 5 point comes under cluster which is having C1 as centroid. So finally, like this, we have to check the distances. Whichever is minimum, that point comes under that cluster which is having that centroid. So finally, with that process, we got the 3 clusters. So second step is again, first starting we assume the clusters. Next, we need the accurate clusters, accurate centroids. So what we have to do is, here we have to calculate the average of all these points in a cluster. For example, in cluster 1, 4 points are there. So we have to calculate the average of all these 4 points. Finally, we got the 2.25, 6, 5 as new cluster. Like that, every cluster we have to repeat. For cluster 3, we have only 1 point. So we no need to calculate the mean value there. This is final cluster. So here 3 clusters we got. Okay, next, again we have to repeat the same. Again, we have to take this one as centroid, and we have to calculate the accurate distances from this centroid to every other point in the data sets. every other point from that new cluster, new centroid to this every other point. Then we got the new cluster. We got the new clusters. See here, the centroids have not changed to the here in this step and this in this step. There are no changes in clusters. So algorithm reached to convergent state. So these are the final clusters we got in K-means algorithm. This is another problem. Again, we have taken few points as input and K value is here 2. So here we need two clusters. Again, we have to do the same. We randomly choose the two centroids and calculate the distance from this centroid to every other point. And we have to check from this point whichever centroid is nearer. Then that point go to that cluster, whichever is minimum, water distance is minimum. So we got the based on minimum distances, we got the two clusters. So here we need the accurate centroids. So we calculate the average of all these points. So again calculate the distance from to this new centroid to every other point. So here also clusters not changed. So algorithm reaches to convergence state. This is another problem, but here we added outliers. This problem is with outliers. See here k value is 2. These are the points. Randomly we pick two centroids. So we calculate the distances from every other point to these centroids. So finally, based on the minimum distance, we got the two clusters. So we need the accurate centroid. So we calculate the average of all these points. So we got the new centroids as this one. Repeat the same. Again calculate the distances from these centroids to every other point. So here, these are the new centroids, new clusters. So here also not changed. So these are the final clusters.